Alright, grade 12s, let's have a look at a wonderful example for here. This is a brilliant little question. I'm going to give you a picture again, with very few words here. I've got a circle, center A, that's the small one that's shaded, and its equation is x minus 4 squared plus y minus 6 squared is 26. And you can clearly see that minus 4 becomes 4 there, negative 6, that's the center given. Then we've got a bigger circle here, which I'm going to call it center B, and it's given by the equation x plus 4 squared plus y plus 2 squared is 58. That's the equation. And then the two circles intersect at C and D. Okay, now what I've got is I've got a straight line y equals minus x plus 4 that seems to be passing through those 2 points, C and D. And the first question is going to be to show that the two circles intersect along that line y equals negative x plus 4. So we want to show that the two circles, they intersect, but they're intersecting along the line y equals minus x plus 4. In other words, minus x plus 4, that line goes through those 2 points C and D. So what we really need to do is we can take the big circle and the line, get the coordinates of the points of intersection, do the same with the little circle and the line, get the coordinates of the points of intersection, and if the line and the circle and the line and the big circle and the line and the small circle have the same coordinates of the points of intersection, we know that they intersect along that line. So that's what we're going to do first. So let's have a look. If we start off with let's have a look at number A. So I'm going to start off with the big circle, which is going to be, let's have a look at this, x plus 4 squared plus y plus 2 squared is equal to 58. And you've got your little line there. Okay. Alright, now if we do simultaneous equations with the circle and that line, the big circle and the line, we should get the coordinates of the points of intersection like you did previously. Well, look at that. Y is minus x plus 4. So let's plug it in. So it's x plus 4 squared plus the y now is negative x plus 4. We've still got the plus 2 squared is 58. So what would this be? That's x plus 4 squared plus negative x plus 6 squared is equal to 58. Multiply out, so that's x squared. X times 4 is 4x, doubled is 8x, 4 squared is 16, plus negative x squared is x squared. If you square that, multiply these two, negative 6x doubled is minus 12x. Then we have the plus 36 is 58. And let's solve for x. So x squared plus x squared is 2x squared, 8x minus 12x, negative 4x. Then 16 plus 36 is 52, and that equals 58. So let's create a trinomial. 52 minus 58 is negative 6. Divide throughout by 2, as we normally do, and guess what? We've got a lovely little trinomial that factorizes beautifully, and we have x is equal to 3, or x is equal to negative 1. Now remember, how do we get the y values? Well, we know that y is equal to negative x plus 4. So if we look at 4x is equal to 3, what would your y value be? Would be negative x is 3 plus 4, which is 1. And then for x is equal to negative 1, y would be negative, careful, negative 1 plus 4, which of course is 5. Now if we look at this, we've got for x is 3, y would be 1. For x is negative 1, y is 5. Okay, now let's relate those. If we go up to the diagram, we can clearly see D would be 3 and 1 there, so that would be D, and C would be negative 1 and 5. So let's go and write that there. C is negative 1 and 5, and the coordinates of D would be 3 and 1, just indicating that. So in other words, the big circle and the line intersect at these 2 points. Now let's see what's the little circle doing with the line. So let's write down its equation. The little circle is x minus 4 squared plus y minus 6 squared is equal to 26 there. Let's just double check its equation. There it is. We've got it there. Okay, and it intersects with the line again. So let's have a look. Y is equal to negative x plus 4. Well, let's do simultaneous equations. Plug in the y value there over here. Subtract 6 squared is 26. And let's see if we get the same x values there. This is x minus 4 all squared plus negative x minus 2 squared is 26. X squared minus 8x plus 16 plus x squared. Okay, careful now. Minus x times minus 2 is going to be 2x, and then we double, it's 4x, and then minus 2 all squared is 4, and that's 26. X squared plus x squared, 2x squared minus 4x, because negative 8 plus 4 is negative 4. Then we've got 16 plus 4 is 20, and let's subtract the 26, and guess what? We've got the exact same trinomial as before. Divide by 2, and look at that, we've got exactly, in fact, this is identical, so we can factorize as we did previously. X is equal to 3 or x is equal to negative 1, and we don't even have to worry about getting the y values now because they're exactly the same. So this would be, if x is 3, y is 1, if x is negative 1, y is 5. And once again, you can clearly see that these are the coordinates of the points of intersection of the small circle with the line, but they're exactly the same as the points of intersection of the big circle and the line. So in other words, the two circles intersect along line CD there. Okay, along this line, y equals minus x plus 4. Okay, now the next question said, show that the length of AB is perpendicular to CD. We want to show that these are right angles. Okay, now to do that, we can work out the gradients of CD, the gradients of AB, and multiply and see if we get negative 1. But the important thing is, firstly we need the coordinates of B. But that's easy because if you think about it, there's the equation of the big circle. So the center would be minus 4, minus 2. There it is. Plus 4 becomes minus 4, plus 2, minus 2. There's your center. So let's have a look. I'm going to write down all those coordinates quickly here. In number B, we've got A being the point 4, 6. That's the center of the small circle. The center of the bigger circle is this one. We've got C being minus 1 and 5. We worked it out. And D being that. So let's have a look at the gradients quickly. What is the gradient of AB? Well, that will be negative 2 minus 6 over negative 4 minus 4, which is negative 8 over negative 8, which is 1. Okay, what's the gradient of CD? Well, let's see, it's 1 minus 5 divided by 3 minus negative 1, which is negative 4 over 4, which is negative 1. Now, if you multiply these, the gradient of AB times the gradient of CD is 1 multiplied by negative 1 is negative 1. So therefore, AB is perpendicular to CD. What a lovely question this is.